Hello, my name is Madison, and I'm excited to give you all a look inside the Virginia Institute of Marine Science. At VIMS, I'm a modeler, so I spend all my time on the computer, but I still wanted to show you all my office and what I've been working on. I work in the Environmental Statistics and Transdisciplinary Data Science Lab. My lab aims to bring rigorous statistics and data science to marine research, including quantifying the impacts of policy and management decisions. My research aims to develop a causal spatiotemporal model to quantify how climate change and management have impacted natural oyster reefs in Chesapeake Bay over the past 20 years. But what's a causal spatiotemporal model? Let's break it down. Let's start with spatio, or spatial. This means we're accounting for how things can be related across space, like different river systems or oyster reefs. Temporal means that we're addressing how things vary over time. For example, we could answer questions on how the oyster reef population is declining over time and if time has a significant factor. And causal means exactly what it sounds like. I'm trying to see if oyster management caused oyster populations to grow over time. And if you've taken a stats class, you've probably heard that correlation does not equal causation. And that is definitely true, but this new complex style of modeling, if done correctly, actually can show causation. And causal modeling has only been applied to evaluate environmental policies only a handful of times. Since I'm in modeling and statistics, I do all my research on the computer and in a coding language called R. Let's take a tour. This is the current project I've been working on for my first dissertation chapter, trying to quantify oyster year classes to model changes in recruitment and lifespan over time. Here's the data that I was given. As you can see, this data set is huge. For 12 rivers across 17 years, there are measurements on the amount of spat, or young oysters, and juvenile oysters. I created a subdata set that adds together data for the amount of spat and young oysters per each bin size. We have bin size at 2 millimeters each. And if you're asking yourself, why is this important? It's because humans have been using oyster populations for a very long time, and they have been exploited for a long time as well. There have been many initiatives to try to improve oyster recruitment, which meaning how many oysters are born each year. Now let's look at the data. This is my favorite part of what I do. To visualize the data, I use a function called ggplot. As you can see, the bigger peaks you see at the beginning of each plot, they're separated by year, they show the recruitment. And if you look at 2018 and onward, recruitment has been consistently pretty good. But we're seeing a problem where oysters aren't living for long enough and barely making it to even 4 years old, when historically, oysters could live to be 20 to 25 years old. What I'm working on right now is trying to quantify how long gear classes are lasting year to year and if that lifespan varies over space and time. I haven't gotten around to figuring that out yet, but I hope to within the next year.